question to exercise 1E on ratios, rates, and best buys, page 27 of your textbook. Our do now question is based on exercise 1B on significant figures. Round each of these numbers to two significant figures. Remember, if it's two significant figures, we want everything else to be 0 except for those two figures. Okay? So 3, 5, I know are going to be the first two digits. The 5 after that is an 8. 8 means we round up, so that means we write 3600. What is that symbol I put in the middle between them? Is it an equals? Thank you very much. We draw one of these approximate signs. So 35882 is approximately 3600. For the second example, we have 49,018.47. Seems very specific, so let's round it to two significant figures. I know the 4 and the 9 are significant, so the number or the digit after the 9 is a 0. We round down, so it becomes approximately 49000. No need for the decimals. If you'd like, you're welcome to add a comma, but just make sure that it doesn't look like a decimal, because that would be incorrect. Okay? So 49,000. Any questions about that before I continue? Okay, seems we're pretty set. Let's move on to today's content. There are 3 definitions I need you to write down. And again, if you can write it in shorter form, please do so. The 3 terms are ratios, unitary method, and rate. Copying down these terms and their definitions. Thank you. Ratios, unitary method, and rate. You probably already know some of these words, but we're just going to define the difference between them. And don't worry, we're not going to go through every single example. You're welcome to do these examples in your own time, but I'll just pick a couple of them for us to do together. Can you read that up the back? Lovely. Okay. I'm going to very quickly talk through ratios while you're writing that stuff down. Ratios you're already familiar with, especially if you do food tech. You already know one part of this to one part of this. If you're making eggs, no, you don't make eggs, sorry. You make cake, that's the word I'm looking for. If you're making cake, you might make, for example, add 1 cup of flour to 2 cups of milk. I assume that's a very awful cake recipe. I don't know how to bake, but you get the idea. You're adding different things, right? For comparing quantities, so amounts with the same unit. I can say, for example, 2 cups of milk and 2 cups of flour. That makes sense. I'm going to skip to the third word there, rate. The difference between a rate and a ratio is while a ratio is the same unit, a rate is different unit. So for example, right, if I said, Daniel, you're driving a car, you're driving how fast? Give me a number.
50 kilometers an hour.
Perfect, 50 kilometers an hour. Kilometers per hour. Kilometers and hours are different units. Yeah, so that would be a rate. For example, if I said, well, this person charges $30 an hour for their service. $30 an hour, different units, yeah? Dollars versus hours, so therefore it's a rate. Okay? So 50 kilometers an hour would be a rate, whereas ratio must be the same. What if I said I was still baking the cake and I need 2 eggs per 2 cups of flour? Is that a rate or a ratio? 2 eggs for 2 cups of flour. Ratio or rate? I heard someone very quietly say rate. That is correct, because an egg is not the same as a cup. Yeah, so lovely, they're different units, so it'd be a rate. Thank you very much. The last one I'll talk about a bit later. It's just a unitary method. I'll come back to in a second. So simplify these ratios. I'm going to pick an easy one and then I'll pick a hard one. The first one I'm going to pick is A, and then I'm going to pick B. Let's start with A. Please make sure you write this example down as well. Simplify, of course, we're making it very easy to understand. 3824 is a bit weird, especially if you're trying to make a cake. You probably don't want to have to add 38 cups of flour. So what goes into both 38 and 24? It's just like a fraction. Yeah? What number goes in both 38 and 24? 2. Yeah? 38 divided by 2? 19. 24 divided by 2 is 12. Yeah? So we're doing the exact same thing we would with fractions. 19 and 12. Is there a common factor between 12 and 19? Besides 1, of course. No. And how do you know that? You're right. But why are we so confident? Why does 19 look like a particularly gross number? Well, it is an odd number, yeah, but it's particularly gross. Like 15 is a nice number, isn't it? Why is 19? Thank you very much. 19 is a prime number, so we can't do anything else. We'd leave it there. Okay. The second example here, 2.5, and this, of course, is a colon, or we can say compared to 1 and 1/3. Just like our normal addition, subtraction. It's very confusing if we have different bases, so I'm going to change them to be in the same base. 2.5, I know that's the same as saying 5/2. And 1 and 1/3, thank you, is the same as saying 4/3. That's just our conversion from mixed number to improper fraction. Sounds pretty familiar? Okay. To make them the same base, of course, I know that 2 and 3, the lowest common multiple is 6. So this one I'm going to times everything by 3. And this one I'm going to times everything by 2. So this one becomes 15/6. And this becomes 8/6. Have I stumped anyone? If you're a little bit confused, can you stare at me like you're terrified, please? Okay. All right. What's common between the 15/6 and 8/6? It's not a trick question. What's common? 6. Let's just get rid of the 6. Yeah? And then we're left with 15 and 8. Because they're both denominators, it'd be the same as saying times both sides by 6. You see how it's kind of linked to our linear equations. So you end up with 15 and 8. And I know that there is no common multiple between them. I know the numbers that go into 8 are 1, 2, 4, and 8. They don't really go into 15, besides 1, of course, so we're done. Any questions about ratios? Are we happy for me to move on? Okay, let's move on. Next example here is write these rates in simplest form. It's 120 kilometers every 3 hours. That's probably a lot more confusing than it needs to be, right? How do I change it to 1 hour? If I go 120 kilometers in 3, what do I do to get to 1? Easy, divided by 3, thank you very much. So I'm going to divide it by 3. 120 divided by 3 is 40. And then this one, 3 hours divided by 3 is, of course, 1. Now, how do I write that? Of course, I could write 40 kilometers every 1 hour. Or you can just write that. You guys are familiar with that. 40 kilometers per hour. Done. All right, any questions? Okay. The next step is looking at unitary method. I'm going to move up just to see the definition. The unitary method just means finding one part of the total. If I said, for example, this pack of Oreos is $2, how do you figure out, well, you might say, well, I want to compare it to a different pack of Oreos, see which one's cheaper per Oreo. Yeah, and then we'll say the price per Oreo, price per 100 grams is this much, and you just compare those at the shops. Yeah, so it's done for you, but that's called the unitary method. It just means making or finding one of. Okay, so in this case, it's $300 being divided in the ratio of 2 to 3. Now, how many total parts are there in this? Imagine that we're saying that this side is 2 people and this side is 3 people. How many total people or total parts are there? 5. So what I'm going to do is I'm going to set 300 divided by the 5, which is 60. That is one part. Any questions about that? Okay. It says find the value of the larger portion. The larger portion, of course, is 3. Because I have 3 parts, each one is worth 60. So the 3 times it by the 60 gives me $180. So you notice how I found one part first and then multiplied it out. Okay. I might do one more example and then I'll leave it there for you to do some practice questions. Any problems, any queries about any of the ones I've done previously? Okay. The class is very silent. I'm hoping that means you either find it good and easy, or that means you're going to ask me a ton of questions later. Let's do question A. Which is better value, 5 kilograms of potatoes for 380 or 3 kilograms for 220? There are a few ways you can do this. If you take a valid approach, you will not lose marks. Okay, just to be clear, there's a few ways of doing it. You can pick whichever way you want to do it. You can either try and find the price of 15 kilograms for both sides and compare the price, or you might want to find 1 kilogram and compare the price. Let's try the 1 kilogram approach. So, the first option is this one right here, where we have 5 kilograms for 380. What I'm going to do is I'm going to make it a rate. There we go. 5 kilograms for 380. Okay? Now, what I am going to do now is trying to find 1 kilogram. So, to get from 5 kilograms to 1 kilogram, I divided by 5, didn't I? And if I do it to the left, I do it to the right. Any questions? Okay. So, once we've done that, of course you can use your calculator, 380 divided by 5 means that for every kilo, it is 76 cents. So 1 kilogram is 76 cents. I figured out the cost. All I need to do is do the same thing for the second price and see if it's higher or lower. Yeah, because of course you don't want to spend more money than you need to. Now, without me actually solving this, just looking at it, which one looks cheaper? 5 kilograms for 380 or 3 kilograms for 220? Hands up if you reckon the 5 kilograms is probably cheaper. Okay, hands up if you reckon the 3 kilograms is probably cheaper. Okay, they're probably very close. Let's see what it looks like. So to do the second component, I'm going to say that 3 kilograms for 220, and then how do I get to 1 kilogram? Of course, I know it's divided by 3. And if I do it to the left, of course, I do it to the right. Gentlemen at the back, are we writing this down? I divide it by 3. So again, I put this in the calculator. I go 220 divided by 3, and I end up with 0.73. So which one's better value, the 5 kilo or 3 kilo bag? 3 kilo bag actually, by 3 cents a kilo. Okay, any questions? All right.